So the first couple of videos that we did involved situations where you're going to have one pretty obvious solution once you've done a little bit of arithmetic. Unfortunately, in algebra, it's not always the case where you're going to end up with situations where you have some obvious solution. But if you have a situation where there is usually just one variable of order one in your equation, you're going to have basically three possibilities. Okay, those three possibilities are going to be that you have um, no solution. You can have exactly one solution, which we've already seen, or you can have an infinite number of solutions. Okay, and this is where you can plug literally any number into each of these equations, or into your equation, and it will work. Okay, I want to talk a little bit about the two ones we haven't seen yet. Okay, the first one I mentioned was the situation where there is no solution. So for the case where there is no solution, okay, you are going to end up with a situation where all of the variables cancel. All variables will cancel. Okay. However, what you're left with, what you what you're left with, uh, I, uh, I'll use a technical math term here and say what you're left with is nonsense. Okay, so you're going to be left with something that doesn't make any sense. Okay, you'll end up with something like 0 is equal to 2, or 5 is equal to 8, right? Something that just doesn't work. All of your variables are gone, so there's nothing you can do to simplify it any further, and you're given something that doesn't make any sense. If you see something like that, that is a situation where you have no solution. Okay. Um, and the other situation you can be left with is where you have an infinite number of solutions. Okay, we have a fancy little symbol we use here. It looks like a sideways 8. We could say infinity solutions, or an infinite number of solutions. Another way you can phrase it is that all real numbers are solutions. Okay, in this situation, all variables all variables will cancel, and you are left with a true statement. Okay, so in this case, you might be left with something like 0 is equal to 0 or 5 is equal to 5. So all of the variables have disappeared. There's nothing that you can do to simplify, um, but you're left with something that's just kind of obviously true. Okay, usually some number is equal to itself. That's basically what you're left with usually in those situations. In that case, you'll have an infinite number of solutions. Okay. So let's look at a couple examples of each of these. The first one I want to look at is, well, I guess I won't spoil it yet, but we'll go through it and we'll see what we get here. Okay, let's say we're given a situation where we have -2 times y plus 1 plus 5y is equal to 3 times y plus 1 minus 2. Okay, so let's go ahead and see how we can simplify this. The first thing I would do is go ahead and distribute where you can. Okay, so let's do that. Let's take this -2 on the left hand side and distribute it to the y and to the 1. So we'll have -2y times 1, or sorry, plus 1 times -2. So they'll just become a -2. We'll have plus 5y. All right. And then on the right-hand side here, we can distribute this 3 to the y and to the 1. So we'll have 3y plus 3, and we'll have -2. So now if we combine like terms, we'll have -2y and 5y. That'll just give us 3y. So we'll have 3y minus 2 is equal to 3y. And here we can combine the 3 and the negative 2. That'll just give us a positive 1. So we'll have 3y plus 1. And you can probably already tell this isn't going to end well, okay? So if we want to see this, let's go ahead and subtract 3y with the goal of trying to isolate the y's by themselves. Well, these will cancel, but so will these, okay? You're left with no more instances of y, but now you're left with negative 2 being equal to positive 1. You can't simplify this any further, and this doesn't make any sense, okay? This is a, quote, nonsense statement, our highly technical math term here, okay? You're left with a nonsense statement. It doesn't work. It doesn't make any sense. So in this situation, we have no solution. Okay, there's nothing you can plug in for x that will make this equation true. Okay, let's look at another example. Let's say we are given, go to the next page here. Let's say we are given negative 6 times x plus 1 plus 8x, and that's going to be equal to 2 times x minus 3. Okay, so now what we can do is we can try to simplify each side. On the left-hand side here, we can distribute this negative 6 to the x and to the 1. So we'll have negative 6x minus 6 plus 8x. Okay. And on the right-hand side here, we can distribute this 2 to the x and to the negative 3. So we'll have 2x minus 6. All right. Now we combine like terms. So we have, on the left-hand side, we have negative 6x and we have 8x. If we combine those two together, we'll get a positive 2x. So we'll have 2x minus 6 is equal to 2x minus 6. And you might be thinking to yourself, duh. So that's probably a good indication that we're going to end up with all real numbers as a possible solution. But just to demonstrate the point, let's go ahead and take 2x away from each side. These will cancel, but so will these. And now we're left with negative 6 is equal to negative 6. So that's obviously true. So that means we're going to have infinite solutions. Okay. To demonstrate this, let's go back to our initial setup here. We have negative 6 times x plus 1 plus 8x. That's going to be equal to 2 times x minus 3. Let's pick a couple of different numbers at random. Let's say we want to see if the number 1, so let's pretend that x is equal to 1. Okay, we'll have, this is going to, if you ever see like a drawn out arrow like this means implies, by the way. So we have x is equal to 1. We have negative 6 times 1 plus 1 plus 8 times 1 is equal to 2 times 1 minus 3. Okay, if we simplify this, we'll get negative 6 times 2 plus 8 is equal to 2 times negative 2. Or here we get negative 12 plus 8 is equal to negative 4. Or negative 4 is equal to negative 4. All right? So that works. That makes the statement true. Let's try x equals 2. If all real numbers work, then I could pick a million and it should work just fine. So x equals 2 implies that we have a negative 6 times 2 plus 1, right? So yeah, 2 plus 1 plus 8 times 2 is equal to 2 times 2 minus 3. So we'll have here negative 6 times 3, so we'll have negative 18 plus 16 is equal to 2 times negative 1, which is negative 2. Or here we have negative 2 is equal to -2. So really, we can pick any number we want, any decimal number, any irrational number, any rational number. It doesn't matter. We can pick any real number that we want, and this situation will work. This equation will work. Okay. And the other option would be there's one solution, but we've already seen that, and we're going to see quite a few more of those. So I'm going to skip that for now. But on your homework, when you get to this section, that is going to be one possibility. So be prepared for a situation where you'll have one solution still.